A lot of cool stuff has been released with version 5.3. Amongst all these new features, I wanted to show you two of them: Nanite Landscape and Tessellation. The latter hasn't been officially announced, and I didn't find any real documentation on it from Epic. As a reminder, tessellation refers to displacement. It's much the same thing. It's an actual deformation of the mesh based on height map. I touched on the subject on one of my previous videos, which you can find here. Let me explain all this black magic to you. If you open any projects that you currently have, here I'm using our Castle Runes pack, and you open a material, you still have the same nodal organization as before. There's no tessellation displacement input yet. We'll be setting up a displacement and a tessellation system directly in the nodal system. To do this, you first need to create something in your default engine.ini, which you can find in the config folder where you first place your project. Of course, you should close your project before doing this. Open it with Notepad and search for script renderer settings. At the bottom of this paragraph, add these two variables. I put it in the description for you guys. If you go back and reopen your project here, open the material again. And now you should see a new input for displacement. To illustrate this method, we will create a plane from modeling tools. Select Create and choose Rectangle. The idea here is to scale it by adjusting its width and depth. And of course to add additional subdivisions to make the tessellation or displacement really effective. Don't hesitate to tick Show Wireframe to make the process easier. Next, we're going to add a nice material using Bridge. Here, I picked the Rocky Forest floor and downloaded it using highest quality settings. After it's downloaded and added in your project, if you take a look at it, as usual, you get one material instance and three textures: the color map, the normal map, and the ORDP here. As we saw in one of my previous videos, here with this map, ORDP stands for occlusion, roughness, and displacement. If you open the texture and filter by channel, you'll see that the red channel corresponds to ambient occlusion, the green channel to roughness, and the blue channel to displacement. And that's what we're going to use. Now, if we jump back to our content browser and create a new material, we'll put in place the overall system. As usual, just drag and drop your textures and place them where they need to be. For the displacement input, I'm going to add extra logics afterward. First, I add a quick and simple UV tile system with the texture coordinates node, a scalar, and a multiply. Then I join the three UV's inputs of each texture to it. For the displacement tessellation input, I simply reproduce the same logic with a multiply and a scalar parameter in order to control the intensity of displacement. Once that's done, if you go back to your scene, create a material instance that you assign to your plane, and let's check our displacement tessellation system via our material instance. And here, if you try to increase the intensity of the displace, nothing happens. This is because tessellation, the way we're currently doing it, is only effective on nanite meshes. This means that we need to activate nanite on our mesh to see the result. To do this, open your content browser, right-click and select nanite at the top. Now, if you play around a bit with your scalar value in your material instance, you'll see something happen, but not quite what we expected. This is because we have to modify some settings in a master material. When you click on the final output, go for its details panel and search for nanite displacement. For example, let's increase the magnitude value to something like 50. If we play with our displacement value in our material instance, we now have actual tessellation displacements on our mesh, using directly our material nodal system. Before we go any further, bear in mind that what I've just shown you isn't in the official 5.3 roadmap. It's really early days and not all of it is optimized for the moment, so just use to try and experiment. To avoid any confusion, we're going to talk about Nanite Landscape, what it really is, and how to mix with the new system of tessellation. This is because the Nanite Landscape, unlike tessellation, is part of the 5.3 roadmap, and the main objective is optimization. So Nanite Landscape is really simple to activate. Just select your landscape, in its detail panel, look for Nanite, tick Enable Nanite, and then build data. Depending on the size of your landscape, this step can take some time. Now, as a classical static mesh, you have all your landscape in Nanite mode. Optimization is now on point for all your scene. Nanite's main objective is to be able to have a large number of triangles and make it work properly, without any lack of optimization. So we're all tempted to mix our Nanite landscape with tessellation. Imagine the possibilities. Let's give it a try. Before presenting the next stages of this tutorial, I've used this project to show the first part, Castle Ruins, which is available on our marketplace. You'll find a complete scene with over 30 photogrammetry assets that we made in the south of France. We had a lot of fun making it, so if you're looking for an environment for your film, cinematics projects, don't hesitate, it's made for you. The links are in the description. Let's try to combine Nanite Landscape and tessellation. We're going to jump to a new level just to make the tutorial easier and simpler to follow. I create a quick setup here, always using environment like Mixer, and also a post-process volume, in order to control exposure as I wish. You have multiple ways to create a landscape, but here I use a height map I created earlier. Using import from file, I choose this file and then import it. I relocate on Z, the landscape, and voila! Same as before, go to the details panel of your landscape, activate Nanite, and build data. Here I picked 3 materials from Bridge to create our landscape's material. I've chosen Ice Cliff, Old Trample, and Snow Covered Ground. To get that snowy feel, create a new material and let's jump into it. You can see we still have our little displacements input as we do earlier. As it is a landscape material, it's going to be a little bit different. For example, here I'm using landscape coords instead of texture coordinates. I've kept the same logic with a scalar and a multiply. We can drop and drag our textures, keeping in mind that our ORDP has displacements in the blue channel. I'm opting for a simple, straightforward approach, but of course, you need to make things a bit more complex and flexible later on to achieve a better final material landscape. Again, same system for our displacement to control intensity afterwards. But here we can't do it like that. As you know, we've downloaded 3 different materials and we have to put everything into one final master material. So here I'm redoing the same operation and the same system configuration for each of them. You quickly realize that we're going to be faced with the problem of connecting everything to a final output. And if we don't specify some logic here, it won't work. Let's disconnect the first one. We're going to place an intermediate node for each of them called Make Material Attributes. This additional intermediate step will help us to deconstruct and reconstruct the whole thing. We can do the same thing for each material. Last intermediate step is to add the node Landscape Layer Blend. This will help us connect everything in one place with just one output. And of course, this is a system we need to create layers that will paint afterward directly in our landscape. Just add array as much as materials layers you have and you want in its details panel. Final step, you see that we have one output facing multiple inputs in the final output result. To fix this, you can select the final output and enable Use Material Attributes in its details panel. Oh, and don't forget to change the sampler source of each textures from texture asset to shared warp. This avoids visual artifacts and allows a greater number of textures to be used in one material. Now everything is in order, you can create a material instance from this material, and we can go to landscape mode and choose the paint mode. Assign the material instance to the landscape, and you should see now on the left layers appearing. To activate them, click on the plus icon to create layer info and choose Weight Blended layer normal. Save it where you want and do the same for each layer. To use the first layer as a base layer, right-click on the layer you want, in this case the ground, and click on Fill Layer. If nothing appears like here, we probably need to rebuild data from your landscape. First things first, let's fix this UV tiling. Open your material instance and lower the value of the UV tile of your material you've chosen as base layer. Here, ground. If you zoom in to see the details, you don't have tessellation for the moment, just nice, good looking normals. Let's create actual and real displays. Just increase the scalar parameter of the material you are currently using. And now we have a real tessellation in our landscape. Let's continue and paint extra layers with additional materials we created earlier. Select a new and adjust your brush settings. Don't forget to also adjust the displace intensity in the first place. Let's go with the last material. And this is really fantastic. Just imagine what you can do with a real topological relief. Even at great distance, you'll see the real shadows and real displays. That's all for today, and don't forget that tessellation is still in its experimental stage, and that optimization isn't really up to scratch. I can't wait to see the future and what the developers at Epic are going to do with all these possibilities. I hope you enjoyed this topic, and I'll see you next Thursday with some control rigs tutorial. Bye!